I tell you one thing about LinkedIn. No matter how well I know you, I'm never sending you a birthday greeting via LinkedIn. And don't take it personally. It's just those two worlds don't belong together, in my opinion. So again, let me echo Bob's thanks for everybody to show up on a nice August night here in Atlanta. I'm Tom, and I've been around for a while. And I'm going to give you not the perspective of an enterprise IT guy, which is what I am these days working for Dell, but just kind of myself as a SMPTE member and what I see in the industry happening, because I'm always looking at interesting trends, you know, like the pre-roll thing I was just saying. You know, in my mind, I go, well, you got to call it something. So what should we call it? So a lot of this is just me thinking out loud. And I hope that when I say something that just does not compute, you'll call BS on me and we'll end up having like a really good conversation about this, because this is all very new. Well, it's not new. How long have we been talking about uncompressed video flows over IP networks, right? So it's not in its infancy. It's not just like been discovered, but I think it's safe to say that, what are there 20, 25 IP deployments worldwide? Are there more than that? Are there 50? I don't know. But compared to, anyway, you guys know the story. So this is a pitch that every enterprise IT person can talk to you about. And they talk about, you know, the changes that happen in a traditional industry when something like Uber addresses the taxi, you know, so that's the digital transformation. The IT transformation, we talk about colo and cloud. Workforce and security, those are actually closer to our hearts. But what I'm going to do is take these enterprise IT transformations and I'm going to reframe them, if you will, into media and entertainment terms. And so the first thing that I would say, I would call it a digital transformation because we're already digital. So maybe transformation is the wrong word. But what I will express is a general trend from a top-down, you know, single source of network truth in a hierarchical organization to a matrix or a fabric of interconnected nodes. And this is a theme we're going to be revisiting again and again, because the tradition of an RF transmitter, one-to-many broadcasting, do we need to get somebody in there? The tradition of one-to-many broadcasting has transmogrified and changed and turned into a number of things. And I'm calling it here for the purposes of discussion, a service mesh architecture. Because we think we're in the television business, but we're actually in the entertainment services delivery business. And so we're going to return to how that transformation changes the technology, because the technology itself is formed off of what our customers are asking. So again, instead of a traditional content distribution network being a Gigandi origin server and then up to edge caches and out to end user appliances. Now we're seeing things like Michelle Munson's new company, who she did Aspera. And so now she's talking about a decentralized content fabric, nothing short of remaking the entire internet to make it more friendly towards video. And I'm like, rock on, that is exactly what we want. Because the internet is not as good as RF or cable or it's just not. How many times have you had buffering on your Netflix and we all just kind of think that that's okay somehow? Broadcast engineers were the original high availability engineer, and we did it in the classic, you know, hot, cold A/B failover, which to an enterprise IT person is like kind of wasteful. You know, we want to go for N+1 redundancy, and we get the whole kind of node structure. And so this is exactly what I'm talking about, is how the concepts that were originally started through with broadcast engineering are now being used. It's like M&E types are being encouraged to adopt the workflow and infrastructure of enterprise IT, but they still remember that they did it first. So that's the digital transformation. We all know how to virtualize any server-based application. It could be like an M&E application like broadcast playout, but anyway, server applications aren't that interesting anymore. What is cool is virtualizing creative seats, you know, running, being able to spin up 30 seats of Avid in 20 minutes, put all those people onto that project, and then spin them down. So virtualization of creative seats is super interesting. This business about workflow orchestration, I'm going to get to that again and again and again, because I honestly think that what used to be called 10 years ago was an enterprise service bus. And these are all enterprise IT things. Those didn't, okay, IBM did this thing with a service-oriented architecture for M&E, and it cost $1 bazillion, and it really wasn't adopted that well. But what we're seeing now, imagine, if you will, a layer down here of infrastructure and a layer up here of applications. In a perfect world, there would be a layer in the middle composed of APIs that are neutral and, you know, kumbaya, we're all going to get together and agree on what they are. Politically speaking, that'll never happen, so there might be 2 or 3 layers in the middle, but the infrastructure will write to one of those API layers. The applications will read and write from one of those API layers. And that, to me, is the true nirvana of an API-driven workflow orchestration, because that will, you could be a piece of software and I could talk to you like you're a black box, a chunk of hardware. You could be a chunk of hardware and talk to me, a piece of software, and tell me what to do. And I believe that more than anything is the main takeaway from what I'm talking about, the future of our entertainment services delivery. I mentioned before being able to spin up 30 editors in 20 minutes and to put them on a project collaboratively and then spin them down instead of having to do the licenses and the, you know, just building a bay takes what, a couple of weeks minimum, and then getting the stuff in and then getting an editor. No, if you've only got a commitment from Netflix for a pilot and you need to spin up something very quickly with minimal, with zero CapEx and minimal OpEx until your pilot gets picked up to series, then you can do whatever you want. But this is something that just started to happen in NAB of this year, is we started to see virtualizing of creative seats, and not just editorial, which is compressed, of course, but color correction and very high bandwidth, low latency creative applications. So that's pretty cool. The multi-cloud, I'm just going to get into that later, but I will say that enterprise storage companies, of whom I work for one, would always describe things like the edge to the core to the cloud. And the core would always be file-based, you know, it's like a StorNext SAN or a chunk of Isilon or a chunk of NetApp or whatever you've got. Well, that is different. And you know who's pointed that out to me first is the esports companies. Because these esports, the big operators like Blizzard and Riot Games, they will have an object store that functions like a shared tape library or a shared asset library of some kind. And the file-based stuff for the low latency, high throughput workflows, that's the new edge. And so this redefining of what is the edge and what is the core is a very important trend happening in enterprise IT. And it's super interesting to me that the esports people have figured that out, because that's truly, that plays into remote production, which is another trend that we're going to see. And we've seen remote production from everything from like the Rio Olympics was the first one I was involved with. And anyway, blah, blah, blah. So, okay, you're going to get this presentation after. I encourage everybody to go look at this Vimeo webinar about the TPN, because once again, if you're like working on a Marvel picture and you have to do MPAA security, then it's a hierarchical thing, right? There's a root of trust, and you have to figure out how you belong to that root of trust in order to be certified. So now, just like we've seen a root type hierarchical CDN turn into a decentralized content fabric, we're seeing the relationship of trust turn into a decentralized relationship. So it's like, I trust you and you trust me, and because you trust me and I trust you, you guys can do business together. That's what the TPN's all about. Plus it's a lot cheaper. You got to pay the MPA, you got to pay Deloitte or somebody 60 grand just to get an MPA audit. And for small shops, that's just not going to happen, right? So these moving from a hierarchical single point of truth to a node-based relationship or a cluster, we're going to see that theme again and again. Have you guys seen this from, you know, Devoncroft and the IABM? They post at NAB and at IBC and things like that. I never know if people fit, you guys probably all fill in that big broadcast survey from Devoncroft, right? So I never know, excuse me, whether me as a manufacturer, whether I should take that kind of stuff seriously, because multi-platform content delivery has been on the top of the pile since as long as I can remember. And yet, I think that some of those other ones, anyway, I just think that every facility is different and everybody is constrained by capital. And that's something that we're going to be referring to again and again, is like, we don't live in a perfect world. We can't just do things because it's the right thing to do, or because it's, not every build is a greenfield build. You do what you can with the capital that you have. Sometimes purchasing decisions are made because of when the maintenance contract on the old stuff is running out, not because you want or have to buy the new thing. So as a manufacturer, I live and die by these kind of standards. And so real quick show of hands. How many people think multi-platform content delivery is the most important priority? Yeah? Anybody not think that UHD production and delivery is second? And like, why is security, cybersecurity, in the middle? Where's my little pointer there? Oh, right, this is okay, yeah. Anyway, I personally think that cybersecurity is hugely important, but not in the way that we think. If you can hack into the air conditioning system of a television facility and shut down the air conditioning, that's far easier and far more effective than hacking into their network stuff or their cloud security or whatever. So I think that security should be much, much higher up on the list. But anyway, I'm just showing you kind of, this is what passes for market intelligence among manufacturers trying to sell stuff into broadcast. Everybody's here is SMPTE, so I assume everybody's kind of a broadcast engineer. Would anybody describe themselves as an enterprise IT guy? Everybody's hardcore broadcast. Yes? 1, 2, okay. 3, getting there? No? Yeah. So when I look at 2 years ago, in the Joint Task Force on Networked Media, posited, this is the first thing that I was aware of this concept. They posited the following points had to be true for it to become a dematerialized facility. And so you can read it there. It's either generic COTS, you know what I mean by COTS, common off the shelf. Generic COTS hardware, either in your facility or in somebody else's. And that's all the cloud is, right? It's somebody else's compute in a facility that you don't own. So it was like cloud. Anyway, whatever. But it has to run on virtual machines, which is very interesting because 2 years ago, you could not push very much through a virtual NIC. If you're in a VMware environment or another hypervisor, you had to drop down into pass-through mode to use the network interface, which kind of defeats the purpose of being in a virtualized environment altogether. So that was very forward thinking of them to say that this dematerialized facility had to run on virtual machines. Open architecture using self-describing APIs. Well, you've heard me already. You know that they're singing my song right there. And in the same way that the discoverability packets of an ST2110 stream self-identify so that they can tell the system, whoops, I gotta stop doing that. They can tell the system, this is who I am. This is a radical idea because remember what I was saying about the layer of applications up here and the layer of infrastructure down here? Well, device drivers is how we used to communicate there. And that's why software took so long and was so hard to do, is because some poor schmuck, first year student or school is sitting there writing device drivers that are the crucial, most important thing in there. And, oh, the thing has been updated, another device driver, another 6 months. Honestly, I think that if we could replace that with this layer of APIs that I keep talking about, so that I don't care if you hardware change and you software change and you workflow comes up with something totally different, it's not going to matter, because as long as it writes to the same API and obeys the same call, you can swap out bits and pieces of your workflow. And we all know how important agility is as these new workflows come up and operations asks us to do something and we don't know what the heck it's going to do. If you're able to swap out new bits of hardware and software and know that the APIs will keep it working, nirvana, seriously. So how far are we on this actual journey? In my bio there, it said that I started at Silicon Graphics. Some of you will remember spending $500,000 on a machine that did one MIP. But we thought it was the bee's knees at the time, and it was, to be honest. But it's interesting that what they called the geometry engines back then, you know, it was an S100 bus board about that big, and it had these custom chips on it. Nowadays, that's a $100 GPU from NVIDIA, right? That's where all that technology from SGI went in doing 3D transformations in real time in hardware. That all went into a GPU. So that's the hardware days a long time ago. Then we got into generic software and we started realizing that all these applications were moving to a subscription-based pricing model so that they could continue to get us to pony up cash year after year after year. I was working for a software company at the time. And now we're into this transition to IP. And honestly, with apologies to Mark Andreessen, I gotta say that there's nothing wrong with serial digital. In fact, I love serial digital. There's nothing wrong with fiber channel. There's nothing wrong with like RS-422, but Ethernet has eaten the world. There's just so many developers working on IP technology, on interesting things, and we're gonna get down, I know I'm talking about all this high level stuff, we're gonna get down into some of the low level stuff in a bit. And it's just impossible to compete with the economies of scale represented by the sheer number and scope of IP developments. And so, you know, lay on Macduff, let's go. The virtualization is all the way back from that JTNM description of a dematerialized facility. And it's now only just starting to come true. And I'm going to show you why. And if anybody wants to, if anybody runs VMware and is interested, see me afterwards and I'll give you a copy of the white paper that explains how to do this in ESX 6.7. But are we really here yet? Are we really at the next level, the so-called multi-cloud? People talk about a hybrid cloud when it's partly on-prem. You know, I can buy object storage. I can get open source. I can get commercial. I can get a ton of different object stores. I can run them on various bits and pieces of hardware. I can run them on-prem. I can rent them in somebody's cloud. I can offer a private cloud to my customers if I'm a large media facility. Healthcare providers are often, not healthcare providers, human genomics researchers and bioinformatics are often establishing a private cloud. It's just object storage running in some colo somewhere. Because part of the terms of service of the public cloud vendors is that if you put your data in there, they've got your data. And for bioinformatics companies, the data is the company. So you cannot let that go out. And that's why private cloud is very, very important to the bioinformatics and the people looking for DNA-based drug research and that kind of thing. It's really cool stuff. So, sorry, we are not there yet. There are ways to do cloud arbitrage today because, hey, who knew? Amazon has sales, right? If I'm running a workload in something and all of a sudden I can run that workload over in another public cloud for cheaper, well, you sure bet that I want to move that over. But for reasons, as the kids say, that's not easy to do. So we're not quite there yet. We're somewhere in between virtualization and the goal of multi-cloud. This is another way of saying that exact same slide. This is from the Ames roadmap just recently, showing what exists. We're somewhere in between the ST standards and the discovery and registration. PTP is close to being done. In any case, we need the whole bit and we need it to work. And that's why those interops that we go to figure out, can you do this broadcast manufacturer's virtual software running on Cisco converged infrastructure with an Arista switch? And you've got to know that if you're an integrator or somebody planning an IP-based facility, because it's maybe 90% of the way there, but boy, you sure don't want to get bit in the behind by the last 10%. So this is just another way of saying back there, this is for your right brain folks, and this is for your left brain folks. So this is the VMware white paper that I was talking about. and I'm not supposed to be salesy, and VMware is a Dell Technologies company, so I'm just going to say, if you're interested in tuning a virtual environment with virtual NICs for very, very low latency stuff, then I'll give you the white paper. Or you can just Google media and entertainment workloads on vSphere 6.7 and probably get it yourself. So what is going to happen to get us that last 20% to the multi-cloud virtualization nirvana? We know that we can do many, many workloads on general purpose CPUs. But come on, kids, we're pushing pixels here. We cannot just assume that CPUs are going to be fast enough and that application software is going to be nimble enough to work out of the box on virtual CPUs. So you got to have some kind of an accelerated compute. And right now that means GPUs and FPGAs. So, oh, sorry, I'm one slide behind. Whee, there's my little animation. This is a Mellanox NIC that has an FPGA right on board. This is not a new concept. Do you remember TCP/IP offload accelerator NICs, TOE NICs? This is the same thing. It's just that instead of an ASIC or a special purpose circuit that does the TCP/IP offloading so that you're not hitting the CPU every time you process an Ethernet packet, you do it right on the card. This is the exact same concept, but hey presto, look, it's Kintex there is the FPGA from Xilinx, of course, because Xilinx makes practically all the FPGAs in the known universe. The ConnectX is actually a PCIe switch. And this is really important because the other thing I'm going to rail on is the lack of PCIe 3 bus bandwidth in nearly every computer you touch. And when we're talking about pushing pixels at the volume of any one of the TV enterprises that you work for, it's very rare that you have a machine, especially a COTS machine, that has enough PCIe 3 bus bandwidth to do what we're asking it to do. So, okay, that was a diversion. That was a digression, sorry. The PCIe switch is the ConnectX 5. The Kintex is the FPGA, and the rest of it, just going internet into the PCIe bus and then off to the CPU, is the NIC. And the ability to have a NIC with a FPGA that can have programmable code modules loaded onto it means that you can do stuff like all that ST2110 stuff. You can do that right on the NIC, hitless switching, right? IGMP joins and drops right in the NIC. And because I'm telling you that there's not enough PCIe bus bandwidth to go around, anything that doesn't have to go to the CPU, use up some system memory, cross the PCIe bus, go to the GPU or go to the FPGA or whatever it is, and then come back the same way. Anytime you can avoid all those hops and all that latency and free up some bus bandwidth for other applications use, then you're in the swim. And in fact, this is from NVIDIA saying exactly the same thing, except this time they're doing GPUs. So the purple thing is the PCIe switch. The green thing is the GPU. That funny little slot is supposed to be system memory. And the idea is, look how many hops you have to go across the bus. You have to go from the, okay, let's say you come in from the NIC, from the right-hand side, and you have to go to the PCI switch, then you have to get some system memory as a bounce buffer from there. So you're crossing the PCI, then you go again across the PCIe bus to the GPU, do those computations. Blazingly fast, yes, but it's been so much trouble and so much latency to get into the darn GPU that it's not that it's not worth the trouble, but it can be improved. And the way it can be improved is to totally not reserve system resources out of the CPU system memory, the bounce buffer as they call it, but just to go directly from the NIC to the GPU and back again. And that's what we're seeing now in these. In fact, you know what I love about media and entertainment? We are such adaptable chameleons. We are grabbing, this concept is from artificial intelligence, because of course these AI guys are as prone to multiple concurrent streams of data needing to hit the GPU, get processed real fast, and get the results out real fast. All of that innovation is coming from artificial intelligence. Only the buzziest topic in the world at this particular moment in 2019. But anyway, we can take advantage of these innovations that are coming from other verticals like artificial intelligence, and single stream throughput is actually being driven by ADAS, self-driving cars, but that doesn't matter. We're talking about media and entertainment. Anyway, this is cool, and avoiding crossing the PCIe bus, avoiding use of system resources, system memory, and getting your data to the GPU and out of the GPU as quick as possible. That's the design goal for people using compute accelerators to push pixels in real-time video flows. So here's NVIDIA's thing saying, you know, the latency looks like that when you're doing it normally. Hey, what other industry is super interested in that beautiful blue, smooth, low latency curve? Why could it be media and entertainment? I think you're right. So these are things that we can totally take advantage of, because in our business, as we're adopting these enterprise IT techniques and infrastructure, latency is the enemy. And anything that we can do to shorten the hops across the network stack, shorten the hops across the PCIe 3 bus, and not have to go to system memory every time we process a network packet, that will, if you're designing a system that needs that low latency to push video for like 24 hours without dropping a single frame, I don't want to see no buffering if this is my media application. Anyway, so this is cool, and it comes from artificial intelligence. Actually, they're driving a lot of the development in this, because really, there's only a few broadcast ISVs that are doing this. What do you got? Evertz, Imagine, Ross, Grass. Maybe there's some small, Sam. Yeah, that's right. Actually, I forgot. And so we're just not big enough to drive the amount of innovation required to put something like this, and yet we can totally glom onto these features, these innovations being done in another vertical, and use them. That truly is the beauty of enterprise IT technology, is it's not in a silo, it's available to everybody. Somebody invents a better NIC or a better offload processor or whatever, and all of a sudden we can just take use of it, make use of it. So I started to say about the edge, the inversion of the edge, and let me think. Again, this is coming from 5G networks and from self-driving cars and from things like that. And 5G networks are super important because Captain Obvious says apparently the kids are watching TV on these things. And so 5G networks are super important, and they are being used by telcos, network providers, and people that need very, very, very low latency processing. Like if you're trying to tell a car not to crash into that thing that just walked in front of it, that processing has to be right on board. But you can't have all processing on board, so some of it has to be put off to the edge. And managing the amount of processing and where it's happening is a really interesting thing right now that's happening more on kind of telco circles and things like that. But as I say, because of media, we get to take advantage of innovations that are happening in other verticals. So analytics is a good example too, because if you have to prepare a report, let's say that you're doing your traffic systems report for the quarter or whatever. Fine, you can take a couple of days and you can crunch that report, however you want. You can make use of whatever available compute you have. But if it's something really critical, like a real-time analytics report that's going to determine whether you run this kind of program or that kind of program in the next 15 minutes, ideally you want to be able to spin up 10,000 cores in a minute, have them all go in parallel, crunch through the analytics required to produce that report and give you that report in 15 minutes. Then you spin down those 10,000 cores because you only use them for 15 minutes, so it really doesn't cost you that much. And that metaphor of being able to do processing fast by bringing a lot of edge nodes to play, or a lot of processing nodes to play, is kind of the middle step between on-prem and the cloud. It's like, the metaphor that I always use is rocks, pebbles, and sand. The rocks being the fully capitalized on-prem assets that everybody uses, that you all share. And then the pebbles being the project-based, usually OpEx, and hopefully you charge it to the individual project. And then the sand is the burstable resources that we all need in the last 2 months of the picture to make sure that it gets finished on the deadline. So you got to have that balanced approach. If I was a power company, it would be something like nuclear power keeps me going at 40% of my thing, and that is always on because it's hard to stop and start. And then coal or something like that is my middle layer, and then natural gas would be my burst. You know, you got to have all those layers. The best thing about enterprise IT is the sheer range of software that's available for control systems, because there's no way that a media and entertainment person by themselves is going to be able to write a sophisticated control system to manage the rocks, pebbles, and the sand. But there are plenty of, I call them opsware, which was one of the first software products to manage data center stuff. There's plenty of opsware type tools out there that can manage your compute and your analytics when you're working in that 3-stage model of rocks, pebbles, and sand. So, you know, high performance storage, right? I come from a storage company. All flash is pretty darn cool. It does high IOPS, it does high throughput, and the cost is coming down. So all flash has changed just about everything that we think of as storage. And now, of course, there's a new category. People call it different things. Storage class memory is what most people are starting to call it. You've heard it called NVMe or NVDIMMs. There's a bunch of different technologies, but they basically mean something that's as fast as RAM and doesn't lose its mind when the power goes off. Storage class memory is being used for, you remember how you used to have like well, forget it, I'm just telling old stories. I'm just saying that SSDs have changed everybody's life, and they are continuing to get faster and better. And after SSDs, even things like 3D NAND SSDs, so seriously, they have 15 terabyte SSDs, you know, in a form factor like that. I can fit almost a petabyte in 4U. It's crazy dense. So it's kind of cool. Expensive, but for some people, it's worth the money. And better power, better cooling. So, and like, I don't know, data protection, is it fair to say that we should just stick a stake in the heart of RAID and let it die? There are so many better, erasure coding is one of them that object stores use. Erasure coding is a very, very clever mathematical abstraction. Now, RAID was clever for its day, but think about the RAID rebuild times on a RAID 6 shelf with 10 or 12 terabyte drives. It's like you're basically out of service for more than 24 hours while you rebuild that array. So erasure coding and newer methods of data protection are finally going to stick a stake in the heart of RAID. So multi-cloud is what I was referring to before, and maybe I'm going to use an example rather than just talk about it. These days, if you get a chunk of storage from Amazon or whatever, like, it's okay, and you can pay if you want it performant, and you can pay if you want it persistent, and you can pay if you want to do this, and pay if you want to get your data out, and pay and pay and pay and pay and pay. So one of the ways that people are dealing with the cloud is to say, look, I love cloud for compute. I'll give you an example. One of the 6 largest VFX companies in the world, there's only 6 of the majors, and it's one of them. They do all their compute in GCP, and they don't do any of their storage in the public cloud. They have their storage on-prem, and they have multiple 100 gigabit links to, in this case, GCP, so that the storage is on-prem and the compute is in the cloud. That's the way they've decided to make their workflow. I'm not saying that's right for everybody. I'm just saying that performance storage, let me say it another way. Compute is useless without performance storage. Just like we were saying that it's tough to get that data into the GPU. And then once it's in there, it goes really fast. And then it's tough to get that data back out again. Same thing with rendering in the cloud. Unless you have performance storage tightly coupled to your compute resources, then you're just spending spending a lot of time moving stuff around to not very good. So there's starting to become a couple of different models. You can actually park your own physical performance storage in a Google Colo. You can have somebody, such as a mid-tier data center operator like Faction or Equinix or one of those, buy the performance storage and manage it for you, also in the Colo. We are not quite at this third level yet, when you can get performant storage, all flash storage, tightly coupled with your rendering. Mostly that hasn't mattered to date because rendering, which is the main market for this kind of architecture, has been CPU bound. So guess what's happening to rendering? Game engines, Unreal, Unity, Cry, all this stuff that's near photorealistic because of the NVIDIA RTX series GPUs, those are way better than previs, and they're giving actual rendered VFX a run for their money. Fine, they will never replace the top 6 majors because those guys pretty much develop custom code for every single picture. And that's how they get the jobs, is by showing that they have written something custom so that they can show, you know, Iron Man breaking the buildings in a more photorealistic way, or physically constrained, or dynamic simulations or whatever. But the growth is not in blockbuster pictures, of which there's 2 or 3 a year per studio. The growth is in mid-tier television VFX. And because of Netflix, because of a lot of things, there is a huge growth in the tier 2 facilities are all pretty much busy. I'm talking about just post-production now. And the tier 3 facilities are scrapping around trying to figure out how to get that. And if you can take your previs rendering all the way from storyboards to, what you don't call it a Leica reel anymore, an animatic, I guess is that what you call it? And do your previs all the way through, and then instead of throwing away your data, you just keep making it better and better and better and better and better until it's, who was it that said no creative project is ever finished? You just run out of time, right? So if you can keep that data, live data, that starts as previs and ends up being very close to what you're gonna deliver for the final movie. GPU-based rendering now with Unity and Cry and Unreal Engine is getting incredibly good, as is volumetric capture. So what you're doing is, instead of synthesizing the 3D by 3D modeling it or some other technique, you're basically sampling it. You're having these LiDAR LiDAR at the high end, but you remember Microsoft Kinect? Remember that little Kinect thing? People are doing stuff with Kinect, and Intel has a thing called RealSense. It's $100. It does volumetric capture. It's crummy looking, but here's the lesson of Innovator's Dilemma, right? That Clay Christensen book. It's software. It's got nowhere to go but up. Watch this space. Volumetric capture is turning into some really interesting things. And when you combine that with real-time rendering through a game-based engine, again, very GPU specific, those RTX GPUs, they're not cheap. They're, you know, many thousands of dollars, and they're hot. They're 1650 watts of CMOS will melt plastic, right? This is like crazy heat and power. And I don't know, I've always felt like, yeah, that's another thing. Anyway, this is where you need to be, not just for the high-end feature film rendering now, but for practically anything, is you need to have performance storage coupled with your compute. And so designing that architecture, it really revolves around the thing that we haven't talked about, which is networking. So let's look at networking now. Oh wait, well, I'm calling this software-defined infrastructure, and the only reason I said it that way is because software-defined hardware sounds weird. But that's what I'm talking about, software-defined hardware. When was this? 2015. This was the first, they called it the glass-to-glass demo because there were cameras, but in 2015 there weren't really IP cameras yet, and there certainly weren't IP displays yet. So there's a bunch of converters in there that are conveniently not shown. But this was the ability to shoot video across the continent in a purely software-defined, this is a very much of a telco type of thing. Back in 2015, it was the telcos that were doing software-defined networking. And this just happened to be a video video happens to be the data type that they were pushing across the continent in this software-defined way. But it gave way to all of these software-defined controllers, open APIs, open controllers, and all of that service level bus that has to happen in order to provision these circuits really well. And the telcos, in terms of software-defined networking and what they're calling network function virtualization, they're kind of ahead of the media industry for now. Network function virtualization is really cool because instead of buying a firewall, you know, I'm an ISP or a network operator or a telco or something, and I need to offer you a security or a firewalled service. So I can buy a chunk of hardware firewall, and then I'm constrained to how fast it can process packets. Or I can spin up a software-defined firewall, of which any one instance is much, much slower than that hardware appliance is, but I can spin up 10,000 of them and look at 10,000 packets in parallel. Next, 10,000 packets in parallel. Next. That's where the telcos started getting the idea to software-defined networks and what they're calling network function virtualization. We've taken it a step farther and gone, oop, wrong slide. I'm going to show you another, I'm going to tell you that now we're calling it MFV, media function virtualization. So do you need to have an IP packet encapsulator? Do you need to have a QC, a probe of some kind, something that sends out a packet and comes and checks it back and looks at it and makes sure, you know, signal return integrity and whatnot. So the ability to start doing an encoding, like just being able to spin up a media function such as JPEG 2000 encoding, which is very CPU intensive, to be able to spin that up on demand is incredibly cool. I already said about how keen I am on API-driven workflow orchestration. I'll tell you that this concept actually came from physical supply chains. A company that is manufacturing and has trucks all over the world, or you know, whatever. Coca-Cola, let's say, we're in Atlanta, I'll say Coca-Cola. You got trucks, you got bottling plants, you've got resources. Logistics is what, an X billion-dollar industry, and they figured out that the way to do it was with these API commands. Well, guess what? Somebody like Netflix doing a digital content supply chain is facing the exact same logistical problems as Coca-Cola was with physical logistics, and the same tools apply. And that's why these API tools, where you have a single source of metadata truth, that's the master. If you're going to do B2, well, used to be called EDI, you're basically going to exchange stuff with another commercial entity. But if you want to make some workflows there, or if you want to actually design an app so that I can monitor the whole thing on my phone, these tools are starting to become more ubiquitous in digital media content supply chains. And I think that's cool because there's a lot of money in getting that right. And when people start to believe in APIs, anyway, blah, blah, you've heard me say that already. Data mobility, okay. This is what I like to call data gravity. And the concept is not new. It comes from big data. You know what's funny about artificial intelligence? We used to call it big data, and then we called it analytics, and now we call it artificial intelligence. Hello, it's the same thing it's always been. Structured queries put on deliberately acquired data in order to produce actionable intel. Fine, call it what you want. That's what we're doing. But the point is, video is the biggest data of them all. And when you talk about gravity, let's use the metaphor of, you know, suns and planets. Video is like a black hole, right? It sucks all the stuff to it. And you know that if you're moving, I don't care how big your internet pipe is, if you have to move a petabyte of data, that's going to take a while, okay? And that's what I mean. You can't just say, oh, I'm going to move it over there to save 15 cents. No, because it's going to take me a week of work to move it over there. You have to plan your data. I tell you another thing that never happened when we were in broadcast school is having to become accountants and having to know how to price out each leg of the workflow. You have to price it out. Like, am I doing it with these on-prem resources? Am I going to outsource it to that company? Am I going to put it in the cloud? Well, how am I going to make that decision? Money is the only way to make that decision. And they never told us that we were going to have to learn accounting skills in order to account for the net present value of doing it on-prem as opposed to doing it in the cloud. And that's weird, but whatever. Data mobility means that video is so huge that you can't move it to go and do the application over there. This happens a lot in analytics, where you need to copy all the log files to a chunk of direct attached storage, run the analytics, and then do something with the reports. Nuh-uh. If you're running analytics on video, you have to bring the applications to the data. If you do it the other way around, it's financially ruinous. It's just completely nonsensical. And that's what I mean by data mobility is, yes, we have globally distributed collaborative workflows, but we have to work very, very hard to make sure that we are not moving giant petabyte chunks of video unnecessarily. So there's the innovation. I'm going to wind up with a couple of, I don't know, did I bend your ear already about hyperconverged infrastructure? Everybody's all used to, the enterprise IT kids that were in school when I was in school, you know, you think in terms of server, storage, and networking as 3 different silos. And usually if you're like a director of technology kind of person, you've got 3 people on site. One's your server guy, one's your storage guy, one's your network guy. Now those are all coming together into the same person. And part of it is because of, with hyperconverged infrastructure, you've got compute and network and storage all in one node. And then when you add a node, the storage works together, the network ports all arrange themselves together. Think about, this is a VFX stack about 10 years ago, maybe a little more, when everything was an individual server. And these are all the things that a person, this is particularly specific to post-production or VFX, but you get the point. If you had to upgrade something and you realized that you couldn't upgrade because there was one component that was preventing you from upgrading the entire stack, and then you missed your window and you had to wait a year to get your window again, oh, hyperconverged infrastructure makes that go away. And to be honest, that's why I'm so keen on virtualization. We all work with very, very intense applications that push the metal to its utmost. And so you think, why shouldn't I have all that power of bare metal? Why do I need to put a virtualization layer when it's just sucking resources away from when I want that bare metal power, like, you know? But the answer is mobility, workload mobility. If I can shift the workload seamlessly, frame accurately to another node in my converged infrastructure in order to do whatever maintenance has to happen on that node, and then move it back seamlessly, there, I just saved myself waiting a year for a maintenance window, right? So the whole point of adopting these enterprise IT techniques like virtualization is to give yourself more freedom, to be able to move workloads around on-prem here, on-prem in California, up in the cloud, outsourced there. If you have that kind of workload flexibility, then you start being able to go home at night because a maintenance windows alone is worth the price of using that much out of your resource stack for the virtualization overhead. How are we doing? 49 minutes. Are you bored yet? Do you want me to bend your ear more about software-defined networking? Because I think this is super cool. I said about how the telcos were adopting it because they need to adopt it for 5G networks. But the ability to have, and again, this is that same trend or metaphor or whatever that I was talking about before. Instead of one gigantic Arista carrier class switch that costs 100 grand and has an integrated background, it's the same argument for the serial digital router as opposed to the decentralized bunch of nodes in the ST2110 architecture. The idea is you're getting away from the monolithic thing and devolving it into a matrix of nodes that all communicate together. And the ability, here, I'll show you the picture. The ability to take, what have I got there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got 12 1U switches. And that, okay, I didn't write down the numbers there, but that's equivalent to almost a terabit of bandwidth. Think about what it would cost you to buy a serial digital router. A terabit is like 200 and, no, I got my math wrong. 2,448 3G spigots. Imagine having do you know what it would cost to put in a, and imagine the size and the power and how big of a router that would be. Now we're talking about, what did I say, 12U, 12 individual 1U switches organized in a spine leaf architecture can give you the equivalent of more than 2,000 serial digital 3G ports. And the way they do that, well, this happens to be one example, but what I want to show you is 1, 2, 3, 4, 5, 6, 7, 8. So you got 8U worth of switches. They are 100 gig between the spines and the leaves. The nodes are hanging off of the leaf switches. And so it might be 40 gigs from the leaf switches down to the compute node or the storage node or whatever's on the other end of that IP. But the ability, like I call this the 49th port problem, right? Because let's say you've got 48 ports of something, fiber channel, anything. And all of a sudden you want to add one more node. Whoops, 50 grand to add one port, right? Whereas you can go from this to that relatively inexpensively, having doubled your, well, what was it? It was 132 to 250. So not quite doubled your rack units, your density. And the cabling gets like ferocious, but the software is actually really easy to use. You use the same switches for the spines and the leaf, and you can plug one in and the other, and it's all not self-identifying, not self-recognizing. There's anyway, I forget the term, but they know how to do this really, really well to make very, very flexible software-defined networks out of a ton of multi-rate 1U switches. So it's cool. And again, back to the multi-cloud idea, what we used to call a hybrid cloud, meaning public and private. Now we're calling it multi-cloud because some of it's going to be an object store on-prem, some of it's going to be a private cloud in somebody's colo, and some of it's going to be public cloud. But the idea is, let's say I'm a company that has acquired a number of other companies, by acquisition as a roll-up, and like site A might be a 2D animation house, and site B might be a television station group, and site D might be a 3D animation company or something like that. And the CFO comes to everybody and goes, all right, you guys, get it together, common technology platform. What we're seeing, and again, this comes from the large esports customers, is that by having the equivalent of a shared tape library in the cloud, just an object store, nothing fancy, it's not performant, it's got issues, you have to be very careful to make sure that your object formats, like if you have files on a filer, they conform to POSIX style metadata, naming conventions, etc. When you move that metadata into the cloud, you lose all that POSIX stuff. And then if you have to move it back again, reconstituting it into the file-based metadata, even with like A time, M time, and C time is tough. So you have to have clever software that understands. This is like a MAM on steroids, right? This is like a MAM that understands low-level stuff like POSIX naming conventions, as well as, oh yeah, John Artist over there wants to move that file so that Sally Artist in Korea can pick it up. And this seems to be the way that multi-site station groups are adopting, because it used to be hub and spoke all based on satellite, right? But transponders $1 million a year, so you can't have too many of those spokes. With this, all you need is a 10 gig connection to your nearest Google thing, and you can have what used to cost $1 million a year for much cheaper. So that's really interesting to see how the combination of file-based and object-based is changing the way that we do collaborative production. What innovation technology presentation would be complete without a description of artificial intelligence? Oh, you didn't think I was going to let you get away without that, right? I just want to go through some really interesting things that we showed last at NAB. And obviously, we all know people that have 28 petabytes locked up in a LTO or IBM or Chaparral tape library. And it's really tough to know what to do. Tape is cheap. Tape is great. Once tape gets going, it's 300 megabytes per second sustained. LTO7 is anyway. But I know a broadcaster down south of here. They have two giant tape libraries that they use as active archives, and they use them so much they bent the actuator arm on a tape library. Imagine how long that takes to fix, right? And you're totally out of, you're just, everything's fallen down bad. The wheels have come off, and that takes a long time to fix. So what if you could migrate, instead of having to migrate each generation of LTO just so that some future generation could read it at some point, what if you could migrate it once? Yeah, you have to migrate it once, but put it into an active archive, a disk-based, probably an object store, because when you're talking 28 petabytes, it's probably going to be object storage. There aren't many file systems that can scale that big. And if you could migrate it just once and actually add value during the migration, rather than just migrate it so that you can read it in X years, actually do something. And the something is to have various artificial intelligence agents watch and listen to your media while you are migrating it to do extended metadata. There's tons of university or college sports television and athletics programs. And they might have some clip of some player when they scored their first whatever. And I hate to say this because when the person dies is actually when that clip is the most valuable. And I'm absolutely not wishing for anybody to die. I'm just saying it's a legit thing that you have about 24 hours to find that clip when the person dies, at which time its value drops precipitously. And so if you have an active archive with extended metadata, then you have a hope of monetizing that clip. But not just for extreme examples like a sports player that you have old footage of. What about remastering workflows for Netflix? Netflix has an insatiable thirst for content, so they're taking all of these standard def features that were only ever telesynced to standard def, and you got to know if it's going to be worth it to remaster and clean it up and do it in 4K according to Netflix's QC. And if you don't have metadata about what these things are, then you're just flying blind and you're not going to make any money. Obviously, there's a ton of proprietary metadata formats, and that's why consultants in the industry exist. And if you have a library conversion program, come see me, because I know lots of people that can help you out with your metadata. This is a super interesting case of artificial intelligence. Do you guys know NASCAR, how they do their advertising? It's a very odd model compared to most advertising. You want to be able to count the number of times that you see the logo going around the oval. And so a trained person, this is not an entry though, this is not some kid's cousin. This is a trained person, but it's an entry-level job, but they're not stupid. They know the sport, they know the tools. They're using very sophisticated clipper type technologies that you would use for slow-mo, like an EVS or a Drastic or a K2. They're using really sophisticated stuff to clip out the stuff. And they can get about 2 hours logged in an 8-hour shift. And so there was a POC done for a large telco that has a large managed services video division. And we did it, well, there was a POC done. And they were able to get 66% efficiency by a very simple AI. The AI was trained on car numbers, sponsor logos, and I think it did speech to text as well. Very simple in terms of AI, very doable, and all of a sudden they were able to bump that to a level of efficiency that the telco is now going to offer for that as one of their managed services if you subscribe to their managed service offerings. This I think is cute. Have you guys ever heard of, are these the GANs? Yes. There's a thing in AI called a generative adversarial network, and it's really, really interesting for image-based AI. And this one, which you can look up that example, and you can buy this little thing from Intel that has an ARM CPU and an Intel GPU on a stick. It's called the Moby stick or something like that. And you can start playing around with these. Pix2Pix is a free generative adversarial network tool that runs on TensorFlow, and you can start to do image processing like that. How long has anybody ever actually tried to iMatch a feature when you don't have an EDL? it's really hard. And when I was talking about that earlier example of cleaning up an old standard def feature to remaster in UHD for Netflix, the ability to iMatch off of something where all you've got is a videotape and a bunch of weird reels of old 35 millimeter, or sometimes it's even 16. Anyway, there are AI-based EDL iMatching tools. One of them is called lowercase I match, and it runs in the cloud, and it's real cute, and it works, and people are using it. But there's another example of giving you decision support for remastering old titles so that you can sell them to Netflix. These people don't exist. And Hollywood loves that because you don't have to pay them extra. You don't have to pay them royalties. It's fantastic having lifelike people that are entirely algorithmically generated. And they look really real too. I mean, she looks a little bit fake, but go to LA and you'll see a million women that look just like her. Oops, did I speak loud? Okay, noted. And so this is that thing that I was referring to earlier, is that instead of the kind of gigantic origin server feeding a number of edge caches and out to client devices, the new paradigm for internet-based TV distribution is a decentralized content fabric. And I can't stress enough how much this one simple trend of away from a hierarchical single source of truth down to the edge is being inverted into a mesh of nodes that have a two-way relationship. This is extremely important to the future of, the way all of us watch television, because this is all coming at the same time as 5G networks. In fact, the algorithms that do the network routing are coming directly from the telcos who are putting together software-defined networking for 5G networks. There's a ton of interesting stuff also. The people that do this have made the very important realization that compute is cheaper than storage. And so just-in-time rendering is the way to go, rather than pre-computing 17 versions of your content and storing them. Even on some kind of cheap storage, there's so much content that the storage adds up. And right now, compute is cheaper than storage. There may be some another innovation hiding in the wings, but that's the central realization that makes this so interesting, is that these paradigms of compute being cheaper are what is funding the innovation right now. So that's me. Thank you very much. Have any questions come in from the audience, or are there questions here in the room?
Somebody made a comment. Great stuff. I look forward to the VOD for all the ideas that zip by.
I'm sorry, I didn't understand that.
They said great stuff. I look forward to the VOD for all ideas that zip by.
Oh, gotcha. Okay, cool. I don't know. Should I produce that? Should I become my own little VOD star? As you can tell, I'm very casual and I really enjoy talking about this stuff. But if you disagree with anything, I expect you to say, hey, buddy, that ain't gonna happen in my lifetime. You're just blowing smoke. Because a lot of this is visionary stuff. And visions don't happen, innovation doesn't happen in a straight line. There needs to be the right combination of circumstances in order for any of these innovations that I've talked about to actually hit our lives and make a difference as producers, as developers, or as consumers.
I've got one question.
Sure.
With the advent of a number of technologies that HP, Promise, and QNAP have put together, a petabyte storage and add-on, what impact would that have on both local and cloud storage?
So let me repeat your question, A, for the recording, and B, to make sure I've understood it. With the advent of petabyte storage, now what precisely do you mean by that?
HP, Promise, and QNAP all have devices out there where you can add, it basically starts off a petabyte of
Sure.
storage.
Okay.
And that storage is then expandable,
Yep.
either by units or internal.
Yep. I'm actually not familiar with the HP or the QNAP product, but I am familiar with Dell Technologies product that does that, and I can tell you, if you'll forgive me, how that works. Remember I mentioned that erasure coding was a kind of a better data protection scheme than RAID? Erasure coding also allows you to have a node-based architecture, because if you have 3 1U servers, and they've all got a bit of storage in them, and you have a file system or an operating system that allows them to work together, then what you can do is expand that storage in chunks of whatever without taking it down. And I think that's the main thing, because anybody can sell you a petabyte of storage, and then when you need to add it, you got to copy that all data out, reformat the thing, rebuild your LUNs, put a volume on there, and then put all the data back on. The trick is you want to keep your petabyte and suddenly make this new capability available. And there are a number of what they call scale-out NAS filers available that will do exactly that. And I'm not familiar with the HPE solution, but I can tell you, remember I said that Dell Technologies has this thing it's 924 terabytes in 4U, and that's with the 15 terabyte SSDs. So I know it can be done, but it's using these scale out systems rather than a traditional RAID controller and a bunch of disk shelves type of architecture.
Again, it comes back to the sales talk that they said that there's no, once you add another set of petabytes on top of it, that it's basically becomes virtually one piece, and there's no real transfer or change, or there's no time to change things around and to make the deliverable available on the entire product. The only thing that really bothered me about the whole thing is I said, what is your MTF mean time before failure? And the answer was, we haven't had a failure yet.
Well,
I'm not sure I can buy that.
Yeah. I don't know how to answer that question other than to tell you that research into petabyte scale file systems is the most interesting things because of the vast ginormity of video data that we all deal with. We didn't used to have to worry about this when it was serial digital and a bunch of VTRs, which a VTR, by the way, is a fantastically efficient storage device, but it's optimized only for one type of file, one type of media. And so, you know, things took an hour, and then the tape was self-archiving and you put it on the shelf. It just wasn't, you didn't have to worry about it. Now we have to worry about these things because to have a petabyte's worth of VTRs all online at the same time, that's impractical. And so to have a storage system that is going to provide you with online access to a petabyte of storage while you're growing it or shrinking it or splitting it or doing things like that. I happen to know Dell Technologies does it with their file system called OneFS. There are other parallel file systems such as IBM's GPFS and others that also can address this problem of scaling a petabyte file system. Yes.
Consumer-oriented question. A little while ago, you were talking about how the content providers have figured out a way to save money through the rendering.
Yes.
The network providers charge you when you're streaming, Netflix or whatever.
Yes.
They charge you by how much. They give you different sizes of that you can download, and if you go over that, you have to pay that one month. So is there anything going on where I can still get the same amount of viewing, but not do as much streaming?
The question was, and forgive me if I'm grossly oversimplifying your question here, can we have a better way of compression that will allow me to get better quality stuff out of Netflix without triggering my data cap? Is that fair?
Fair.
And honestly, compression is so cool right now. People are looking at, well, wavelets have been around for a while. JPEG 2000's been around for a while. There are incremental improvements in JPEG 2000 that I really like because of the low latency of JPEG 2000. It's not a consumer codec at all. It's asymmetrical. There's a number of issues about it. But again, these things are held back because of CPU performance. And even though people say that Moore's law is going to have some sort of an end, I think that because we now have the accelerated compute, which was one of the trends, that if you have CPU as the orchestrator and an FPGA dedicated to JPEG 2000 compression as the worker, I think that's how we will see better compression schemes, real-time compression schemes, such as JPEG 2000, start to address that issue of higher quality without more bandwidth.
And this would be purchased by Comcast, AT&T, Verizon.
So as soon as one of them decides that they're going to make their client-facing encoding format into something other than, well, I think we're still using MPEG-2 for half of the deployments that I know about. ProRes is never going to happen because it's too Apple specific. Yes, when Comcast or somebody like that decides that the money that they have to spend to work harder on compressing the stuff is worth it because of a differentiator or something. JPEG 2000 is cool because it can carry system endpoint identifiers, which are useful for HDR stuff. Well, actually, I'm sorry, I'm confusing two things. That's H.265. Forget I said that, I was wrong. It's H.265 that may be the one that meets what you're talking about, because I think the consumer silicon for H.265 is more prevalent than JPEG 2000. Sorry, I totally changed my mind in the middle of answering that question. Tend to do that myself, sorry. Any follow-ups, or are you okay with my babbling on?
Well, the two things real quick. So you're saying one of the three will do it and the other two,
yes,
because of competitive reasons, will have to follow suit.
So standards and licensing, H.265 is probably going to get embroiled in a bunch of patent squabbles, and I'm not a lawyer. I can't tell you what's going to happen out of that. But if the patent squabbles weren't happening, then I would say H.265 would have provided that capability today. But right now, too many people are seeing it as a land grab.
And the other thing is that I understand that Netflix has built a very comprehensive network and that they allow other carriers to use that network.
They don't allow it for free, but yes.
Yeah, right. So well, right.
Yeah.
Could Netflix do that as the content provider do that?
So the question is, Netflix has a very good CDN with edge caching and very, very, very good control over every single packet in their network. It's astoundingly good. And the question is, could Netflix push a new codec standard through? Absolutely. They control their ecosystem end to end, and they're smart and they're good. But they write this, like if I buy a Samsung TV that has a copy of Netflix built into the system on chip, it was a Netflix coder that built that for the system on chip. So they don't control the software rendering when I look at Netflix in my browser, but they do control the Netflix application on this or on my LG TV. Not control, they want to put it as widely as possible, but they write it. They keep all that intellectual property very close to the chest.
Got a question for you.
Sure.
So do you see a huge market space for M&E in autonomous cars and 5G?
You know, autonomous cars, think about it. You're not driving. You're sitting there for an hour, nothing to do. What are you going to do? Your whole car is made out of glass. That entire surface could become a display screen. Corning already has prototype curved display surfaces that are exactly designed for that. I think the prospect is incredibly rosy for all kinds of content, entertainment content, learning content, telepresence, you know, the equivalent of FaceTiming with people, right from inside your little bubble that used to be called a car. I can't say when autonomous driving cars are going to be accepted, but I for sure know that everybody is thinking about that expanse of glass as their new TV. don't even call it a TV anymore. I don't know, whatever display device.
So I got one question here on the stream. That's from Peter. It said, when my content is distributed throughout the network and not centrally stored, even in S3, will there be a MEM that can manage this with a cost optimization engine?
Boy, that's a good question. The question was, when my content's just stored in all of these distributed nodes, what kind of a MEM will there be that understands how to make sense of my content when it's stored all over the place on a distributed node? Right now, I don't know of any MEM that is up to that challenge. I look at these innovations like the decentralized content fabric, and I think that somehow it's going to come out of that. What they do, in fact, let me go back to that slide. Okay, trustless relationship. I think we can all agree that the internet has not lived up to its promise to be a democratic, safe space where everybody can show their best self at all times. And yet we want to make the internet into a better version of a content distribution thing. And so we have to do business with each other where I don't trust you and you don't trust me. I don't even know you. How's that going to happen? Okay, another two buzzwords. Blockchain. There's another buzzword for our innovation presentation. If I know mathematically and can prove the provenance of that content, and I know that I'm gaining some credits by allowing you to store your content on my node, which then I can spend those credits on fetching content from your node. And if the machine the machine routing algorithms are smart enough to know that, okay, the latency means I'm going to get chunk 1 from you. Oh, chunk 2 from that node over there. Hey, that node's got good latency. I'm going to get chunk 3 from that node. And between machine learning controlling those network routing algorithms and blockchain tracing the provenance and proving that you're getting legit content and you're spending your credits for getting your content, but you're also earning credits for being a node in the network. That's why I like this concept so much. It doesn't answer the question that came in from the streaming audience of what MEM can do that, because it doesn't even exist. This doesn't even exist yet, except as a series of 5 research efforts from the team that developed Aspera. It's very cool technology, Eluvio, ELUV.io. But it's just research right now. So I'm sure that they will research and build the underpinnings that will allow a media browser to work in this decentralized system. But we got to get the infrastructure layer working before we can provide that application layer on, the MEM layer on top of the infrastructure. Yes?
You mentioned that a bit about the pharmaceuticals or medical research.
Yes.
Using like colo cloud type stuff.
Yeah.
But you said the other stuff was you're surrendering the data to whoever's doing it. Describe what you mean by that. It's not like giving your pictures to Facebook or something where they own it.
But that's the same thing, basically. Once your pictures are in Facebook, they can do anything they want with your pictures.
So if you're using cloud storage that you think is yours and secure.
Read your terms of service. Most of the deals that you make mean that they can do whatever they want with your data.
And when you say do whatever they want, you're saying they can pull pictures out of that and use it for a commercial somewhere? Or?
Yep. In the specific case of healthcare researchers, their data indicates where they're going to be looking for new drugs. That stuff is worth billions.
Yeah.
So they will not put that anywhere. Financial people are the same thing. Tech data has to be private. It can't go in the public cloud.
And so you're saying that all other cloud storage is otherwise?
I'm sure that if you're really powerful, you can negotiate some sort of an agreement that doesn't give them control over your data. The agreements that I've seen give them control over your data. And so I'm like, okay, I don't care about my pictures necessarily, although I don't necessarily like the idea of, being used to train some AI, which is what they're doing now, this big scandal that's going on. I don't know how I feel about it. But the point is, you have to read your terms of service very, very carefully, because they know that data is like the new capital. You know, if you own data, it's like owning a rental property. You put a little care and feeding into it and it'll keep providing an income stream for you for life. And that's why data is so important. And I can't believe that we all give away our data for free, our data exhaust, when that stuff is worth a lot. Sorry, this is just random musings. This is not me speaking on behalf of Dell Technologies or anything. This is just me as a consumer.
We're drinking out of our fire,
Yeah.
We got one more question.
Sure.
So you mentioned VDI infrastructure for edit.
Yes.
Now, what's the architecture look like? Are you still going to use high-res content, or is it going to be a proxy-based and conform to high-res?
So there are a number of companies. Bebop is probably the best known in this space, and they use compressed video, not proxy, because they don't actually, you know, do a conform against the real stuff. But it's all based on, have you heard of Teradici, this company doing PC over IP, that protocol? So PC over IP used to have a hardware card that lived in your computer, and then it would go to a thin client, like a Wise, you know, little terminal. But now the CPUs are getting fast enough that Teradici's cloud access software is basically a software, a virtualized or software-only version of that same thing. So it can scrape all of the pixels in your frame buffer, compress them, send them down a 1 gig pipe, and then reconstitute them at the other end. So you virtualize a version of Avid, like Media Composer or something like that. You use Teradici to put that out to the remote desktop. The person at the remote desktop, either they might have a thin client. If they're doing interactive stuff like with a Wacom, then yeah, you probably want the hardware client. But if you're just like, you know, reviewing rushes or something, the software client's fine. And again, it's software. It's got nowhere to go but up as CPUs get faster. So basically, in the same way that you, in like a Microsoft Office type of environment, would have a virtual desktop that's good for a knowledge worker, now this is that same concept that is more powerful so that it can be a creative worker doing compositing or editing or even color correction, although color correction, you know, uncompressed UHD stuff is tough. It can be done, but it's tough. You need about 80 megabits to do color correction from New York to LA, for instance.
Especially 444 or 888.
Yeah, I have never worked on an 888 project, but 444, we kind of didn't really do 444, except stereo was 422 and 422, so that's kind of like 444. And I have done stereo color correction projects from New York to California, so that's kind of like what we're talking about.
And then that's to get the video to a desktop monitor. What if you need to get the video to a broadcast monitor?
I would probably not do that as a VDI thing. I would probably do that using some kind of a contribution encoder. Nevion, you know them? They make very good contribution quality encoders that can fit under 100 megabits of very good quality stuff. I'm sorry, when I said 80 megabits, that's for an HD stream, not UHD. Sorry, I don't even know if I answered that question. I just started randomly talking about stuff. Gee, what a theme. I've been doing that all night. Sorry. I can't believe this is being recorded. Is that, are we good? Thank you very much.
Thank you.